Welcome to the Fall 2016 Refresher. This year the weather module focuses on pilot reports. And the reason we're focused on this topic again is because earlier this year the National Transportation Safety Board held a conference in Washington, D.C. on pilot reports, or PIREPs. 23 panelists from public and private institutions and NTSB staff members gave presentations and participated in a discussion on PIREP use, dissemination, training, and future improvements. Representatives from the FAA and ATC were present, as well as CWSU meteorologists. And it became apparent at the conference that the need for more pilot report information is widely accepted by the FAA, general aviation, industry, and the NTSB. Issues regarding controller and pilot solicitation were addressed, as were technology and controller training. And an NTSB report with recommendations for improvements in PIREP observations, retrieval, and distribution will be published this fall. One of the presentations at the conference was given by a controller from Atlanta Center. He stressed that no center does it exactly the same, but in general, the procedures involve paper and walking, something he referred to as the sneaker net. And complaints about PIREP submission process from controllers are similar from center to center. The submission process is distracting from the scopes. ERIDS is not considered a user-friendly system. It frequently lists reports in areas the controller can't use, and frequently there is no access to the internet in AWC displays. So ARTCC controller involvement really has two issues: the inefficient submission process that we know as sneakernet, and the lack of awareness of outside reports from other sources than from within the ARTCC, other than urgent reports. At the beginning of the conference, experts from different public and private agencies described the need for PIREPs from their angle. A meteorologist from the Aviation Weather Center gave 4 bullet points. PIREPs, he said, help validate our forecasts and provide immediate feedback, which ultimately improves safety. They can further increase situational awareness and allow for more timely forecast amendments. They can allow forecasters to maximize operational benefit. In other words, the reports provide information needed to be more specific or highlight new areas of concern. And the fact remains that there is no dense observation network that provides consistent, reliable flow of data from the upper atmosphere like we have at the surface. From the National Center for Atmospheric Research, a research meteorologist emphasized how heavily their work relies on pilot report data. For both icing and turbulence research, PIREPs are frequently the only source of information that confirms conditions for the hazards. In fact, he stressed that null reports, messages that report no problems with icing or turbulence, comprise about 50% of the data used in statistical analysis and are extremely valuable in the research. For example, understanding when no icing occurs during moist conditions is equally important as understanding when it does occur. Representatives from general aviation also mentioned the need for more pilot report information. Here we have the total weather accidents in 2012 broken down by cause. One statistic, the number of accidents in 2012 that occurred due to VFR flights flying into IMC conditions, pointed out the need for more cloud-based and top data. It is felt that more cloud information might reduce the number of serious small plane accidents. The AOPA representative also mentioned the often very broad AirMet forecasts issued by the National Weather Service, and the fact that they are often considered too broad and nonspecific to be as useful as they could be to private pilots. Pilot reports are helpful in narrowing these forecasts down or even confirming the presence of a hazard. A representative from the National Business Aviation Association provided some quotes from industry pilots about the usefulness of pilot reports. The quotes could be summarized to state that PIREPs, as a source of hazard information, get the most attention from pilots. PIREPs reinforce predictions. PIREPs provide information that was not previously known. And bases, tops of clouds, and icing reports are very helpful and not shared enough. To summarize, PIREPs are the only way to confirm conditions. They enable more precise IRMETs and SIGMETs. They provide verification to improve the science and modeling. And the dissemination of PIREPs are critical for aviation safety, pilot and ATC knowledge with more accurate weather forecasts. To enhance the safety of all flights, sharing information should not be a one-way street. Unfortunately, in many centers, access to current pilot report information can be limited. Awareness of controllers to potential weather concerns can be held back by the communication systems as they exist now. Let's talk about the pilot report data that you as a controller may not receive. First, technology is rapidly changing the way pilot information is shared by making use of the internet and mobile software. The Aviation Weather Center now has its own online submission form for PIREPs. Users are required to register, and each account is validated based on a pilot's license, email address, and/or airline ID number. It enables registered users to directly enter information to increase reports and assist other pilots, dispatchers, and flight planners. It is currently used by a few ARTCCs, Southwest Airlines, and about 250 registered general aviation pilots, but they hope for a lot more participation. The information that is sent via the online form ends up directly on the AWC aircraft reports page, along with reports coming from other sources. If you have access to this page on the internet, simply by clicking on a symbol on the map, you get a pop-up that allows you to read the full report. And note that this report near Denver has a code at the end that tells you the source of the PIREP. This one happens to be from flight data at Denver Center. Second, let's take a look at how some airlines retrieve and share pilot report information. Let's look first at Southwest Airlines. In Southwest Flight Operations Manual, there is a requirement that flight crews and dispatchers will communicate known or potential turbulence. Flight deck crews must send turbulence PIREPs to dispatch. When sending turbulence PIREPs, they should include the duration, intensity, altitude, and location of the turbulence. And during flight, the pilot and dispatcher must communicate any changes in the forecast or actual turbulence conditions via ACARS or radio to pass real-time turbulence information to other flights. Note that the pilot report from Southwest, as it would pop up on the AWC website, appears with the SWA tag at the end, and the fact that this report was sent via the internet using the AWC online submission form. Southwest is one of the more prolific users of the online submission form, and this is the way turbulence information is shared with outsiders from the airline. While flight crews may share this information as well with controllers via radio, there is no guarantee that all reports are shared except via the AWC website. Let's take a look at another airline. United Airlines has established an automated way of sharing its reports. PIREPs are sent from the cockpit via an ACARS text transmission to AirInc, which in turn sends the information to the National Weather Service. These reports, filed as AirReps, are then placed into WMO text bulletins for delivery to users and also plotted on the AWC graphic. By clicking on an AirRep, a PIREP A pop-up will reveal the identity of the airline and the flight number given at the beginning of the report. Again, there is no guarantee that a pilot will also share this info directly by radio to a controller. It's assumed that reports are delivered to the FAA via the WMO text bulletins. Aside from the AWC online submission form, there are services that provide direct submission software to pilots. One of these, AeroV, has a free smartphone app that allows for submission to AWC. The interface allows a pilot to quickly describe the conditions and transmit. This app currently has about 5,000 users, but it could handle a lot more. Pilots are also encouraged to send any severe reports to ATC, but there will be many reports without severe that you may not see. Finally, there is the AISR submission form on the internet that is used by FAA agencies such as flight data. PIREPs are distributed as a Service B message along with NOTAMs and flight information. The distribution list includes other FAA facilities, the National Weather Service, where again reports are plotted on the AWC site, airlines, and the military. So collectively, there is a lot of information coming into AWC from sources other than ARTCC's. And much of this you never see unless you are looking at the AWC Aircraft Reports graphic. Are you feeling left out yet? And here is another concern, sometimes voiced by controllers. Why do we even solicit pilot reports? In other words, if pilot reports are so valuable, why don't more pilots just submit reports without us having to ask? Well, surveys by government agencies have been done as to why pilots just don't voluntarily send more information. Let's go through some of the reasons pilots give for not sending pilot reports. Sometimes the reason might have something to do with the fact that everything is going well. It doesn't seem like there is a need to send a report. Maybe the ride is simply uneventful. Maybe there's no demand for pilot report information that they can perceive. Perhaps there's some concerns about the radio, or maybe the cockpit workload, or maybe something about the duplicity of information. Maybe it's just plainly inconvenient, or the process is cumbersome, or maybe they can't remember how to do it. It's clear from as many reasons that requesting information from pilots is worth the effort. If nothing else, it provides a reminder and incentive for pilots to report on flight conditions. Now let's take a look at how the CWSU decides what type of pilot reports are needed from controllers. Well, the basis for our requests really come in two parts: what is out there and what is forecast. It's a good time to remind ourselves when centers need to get reports. FAA air traffic facilities are required to solicit PIREPs when the following conditions are reported or forecast: ceilings at or below 5,000 feet, visibility at or below 5 miles, thunderstorms are present or are forecast to be present, icing of light degree or greater, turbulence of moderate degree or greater, wind shear, or volcanic ash clouds. Let's look at some of these categories. How do we determine, for example, whether or not to request ceiling or visibility PIREPs? Well, do we have current observations? Are there conditions out there that exist? Maybe the issues surrounding them are undiagnosed, but we have current METARs that show low ceilings or visibilities. We'll also look at what's forecast. What are the local effects around an airport? What's the synoptic scenario? Do we have developing approaching storm systems? Maybe are we expecting overnight conditions leading to radiation fog? And we'll also consider other forecaster judgment. What are the current TAFs calling for, and what do the model forecasts say? Again, for icing, taking a look at existing conditions, either through PIREPs or radar, satellite, ceilings as reported on the observations. And we'll also look at what's coming. We'll look at cloud lift formation mechanisms, whether we expect precipitation, what the model guidance is calling for, and whether or not we expect supercooled large drop formation leading to freezing rain or drizzle. This is extremely important because that is hazardous to all aircraft. With upper level turbulence, sometimes we have pilot reports even though we may not know exactly what's going on at the time. We'll look at satellite patterns, also look at existing balloon soundings, and then we'll consider what the patterns are that we're expecting with the jet stream, whether or not we're seeing vertical shear layers, upper troughs moving into the area, difluent flow, what the current turbulence model guidance is showing via the GTG or LROD indices. Out west, they'll look at the possibility of mountain waves, and also thunderstorms have an effect on the presence of upper level turbulence even far away from the thunderstorm. At low levels, it's important to establish the conditions for low level wind shear. If you've got a strong inversion or with a sudden vertical increase in the lower atmosphere, often that leads to not only wind shear but significant low level turbulence, especially for light aircraft. We'll look at the presence of steep low level pressure gradients, maybe leading to strong winds or gusty winds, wind shifts at lower levels, and also the presence of thermals, maybe leading to convection. And finally, thunderstorms really rely on instability and sufficient moisture, leading to strong vertical currents, and then the rapid cumulonimbus development and growth. The need for thunderstorm awareness is obvious, but there are conditions where thunderstorm presence may not be so obvious to you or pilots, and that is why we highlight this possibility on the PIREP board. We may also add comments to narrow the scope of PIREP requests. For example, the abbreviations you see here, E and NW, mean eastern or northwest parts of the control areas are the only concern. Also, we can include a timestamp, which may limit the time of hazard concern for an area. Just keep in mind that there is always a meteorological basis for all requests of PIREP information. And smooth and null reports, even though we're requesting the reports, are very useful. The CWSU will cancel requests if we feel the potential for the hazard is ended, and we will notify OMIC and areas if it is an unscheduled change. There are some future improvements. At the NTSB conference, there was discussion about improvements to the pilot report system, but here at Minneapolis, we are taking actions to improve controller awareness already. Monitors will be installed soon in each area, which will show current PIREP plots from AWC for turbulence and icing, and also show the current ZMP CWSU PIREP request board. In other developments, the ADSB system shows some promise to help communicate ride reports. ADSB is the satellite-based surveillance and positioning system part of NextGen. By 2020, aircraft equipped with the Universal Access Transceiver, that is the ADSB-in technology, will be able to receive weather reports and weather radar through flight information service broadcasts. The ADSB-out part may also have the capability to transmit aircraft measurements of weather data and objective turbulence measurements. And there is currently technology in use by airlines that may increase pilot awareness of conditions, but with information that is not available to anyone except subscribers. The important feature to you about these technologies is that air crews and dispatchers are using this information and making altitude and route decisions. So there may be times when you may not quite understand the reasons for altitude and route requests without seeing the information crews are using. Finally, we get it. Sneakernet is old, inefficient, and antiquated. Your efforts, in spite of the inconvenience, are really appreciated. ARTCC controller solicited reports still provide a large percentage of data that are used for flight safety, routing decisions, and weather research. But expect some NTSB recommendations that address the solicitation and awareness problems, likely involving upgraded controller accessible technology. It's important to stay tuned.